This is B. Ramarao from SRRS Government Polytechnic, Sicily. First year students in diploma first sem common subject general chemistry subject code C104. Today we discuss about covalent bond and oxidation number. What is oxidation number? How do you calculate the oxidation number of atom in a molecule? These topics we discuss in this hour. Objectives. On the completion of this period, you will be able to know covalent bond, oxidation and reduction, oxidation number rules, find the oxidation number of atom in a molecule. On the completion of this period, you would be able to know about covalent bond, oxidation and reduction, oxidation number rules, find the oxidation number of atom in a molecule. What is a covalent bond? How do you form covalent bond in a molecule like hydrogen, oxygen, nitrogen? What is oxidation? What is reduction? What is oxidation number? How do you calculate the oxidation number? By using some rules. In a molecule, an atom, oxidation number calculation by using oxidation number rules. These topics we discuss in this hour. Covalent bond. Covalent bond. The word covalent is a combination of the prefix co from Latin cum meaning with or together and the verb valence meaning to be strong. To be strong. The word covalent is a combination of the prefix co from Latin cum meaning with or together and the verb valence meaning to be strong. Two electrons shared together have the strength to hold two atoms together in a bond. Two electrons shared together have the strength to hold two atoms together in a bond. Two electrons shared together have the strength to hold two atoms together in a bond. Together in a bond. The covalent bond means two electrons shared together have the strength to hold two atoms together in a bond. The strength to hold two atoms together in a bond. Bonds are forces that hold groups of atoms together and make them function as a unit. Force that hold groups of atoms together and make them functions as a unit. Two types: ionic bond, transfer of electrons gained or lost makes formula unit. Covalent bond, sharing of electrons, the resulting particles is called a molecule. Bonds are two types: ionic bond and covalent bond. Forces that hold group of atoms together and make them function as a unit. These are two types: ionic bond, transfer of electrons gained or lost. Makes formula unit. Covalent bond, sharing of electrons. The resulting particles is called molecules. Bonds are ionic and covalent. Forces that hold group of atoms together and make them function as a unit. These are two types of units: transfer of electrons gain or loss makes formula unit. Covalent bond, sharing of electrons, the resulting particle is called a molecule. Sharing of electrons, the resulting particles is called a molecule. Molecules. Many elements found in a nature are in the form of molecules. Many elements found in nature are in the form of molecules. A neutral group of atoms joined together by covalent bond. For example, air contains oxygen molecule consisting of two oxygen atoms joined covalently called diatomic molecule. Many elements found in nature are in the form of molecules. A neutral group of atoms joined together by covalent bond. For example, air contains oxygen molecule consists of two oxygen atoms joined covalent bond called as diatomic molecule. Oxygen valency have only 6 electrons. When 2 electrons less than octet configuration. Another oxygen atom also have 6 electrons, 2 electrons less than octet configuration. Two oxygen atom share 2 unpaired electrons in its valency shell. Oxygen electronic configuration 1s2, 2s2, 2p4, 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 px, py, pj. px pair of electrons, py and pz two unpaired electrons present each oxygen atom. Another oxygen atom also have px one pair of electrons, py and pz two unpaired electrons are possible. These two unpaired electrons are first oxygen atom and second oxygen atom, two unpaired electrons each sharing together to form two new bonds between oxygen to oxygen have a double bond. There are involving in 4 electrons of two oxygen atoms then form two bonds between oxygen to oxygen is called double bond. Double bonds are possible in oxygen molecule. Similarly, a hydrogen atom also have only one electron. This one electron is present hydrogen atom when it is sharing of another hydrogen atom, it get nearest inert gas helium configuration in its valency shell. So hydrogen atom 1s1, another oxygen hydrogen atom also have 1s1 electronic configuration. These two electrons mutual sharing together then form a new bond between hydrogen to hydrogen. Hydrogen molecule present single bond between hydrogen to hydrogen atom. Oxygen molecule present two bonds between oxygen to oxygen. Nitrogen molecule present triple bond between nitrogen to nitrogen atom. Nitrogen electronic configuration 1s2, 2s2, 2p3. 2p3 means px, py, pz. Each orbital contains only one electrons. Its valency present 5 electrons. It is required 3 electrons to get nearest inert gas configuration. So another nitrogen atom also require 3 electrons to get inert gas configuration. So both nitrogen atoms mutual sharing together to form stable nitrogen molecule. Nitrogen px, py, pz. 3 unpaired electrons of first nitrogen atom. Second nitrogen atom px, py, pz. 3 unpaired electrons. These 3 unpaired electrons mutual sharing together to form a new bond between nitrogen to nitrogen, form a triple bond in a nitrogen molecule. Many elements found in nature are in the form of molecule. A neutral group of atoms joined together by covalent bond. For example, air contains oxygen molecule consisting of two oxygen atoms joined covalently, called as diatomic molecule. How does hydrogen atom form hydrogen molecule? Diatomic hydrogen molecule. Diatomic means two hydrogen atoms combine together to form a stable molecule. The nuclei repel each other since they both have a positive charge like charges repel. The nuclei repels each other since they both have a positive charges. But the nuclei are attracted to the electrons. The nuclei attract the electrons. They share the electrons and this is called covalent bond and involves only non-metals. Hydrogen atom present only one electron. These electrons present s orbital. Another hydrogen atom present only one electron in s orbital. These two hydrogen atoms nucleus attract the electrons by sharing of two electrons, then form a covalent bond between hydrogen to hydrogen atoms. How does hydrogen molecule form? But the nucleus are attracted to the electrons. Nucleus present positive charge, electrons present negative charge. These negative charged particles are attracted by the positive charged particle of nucleus. Then the electrons of two hydrogen atoms, they share the electrons, and this is called a covalent bond and involves only non-metals. Sharing of electrons. Atoms that share electrons are called molecules. The atoms can share multiple electrons to obtain a full outer shell of electrons. Atoms that share electrons are called molecules. The atoms can share multiple electrons to obtain a full outer shell of electrons. Hydrogen, 1 electrons. Another hydrogen atom also only 1 electrons in its valence shell. These two electrons mutual sharing together to form hydrogen molecule. In water molecule, ammonia, methane form covalent bond between central atom of oxygen, nitrogen, carbon to hydrogen atom. In water molecule present one oxygen atom, two hydrogen atoms. Ammonia present one nitrogen atom, three hydrogen atoms. Methane present one carbon atom and four hydrogen atoms. Oxygen in its valence shell present two unpaired electrons. Those unpaired electrons mutual sharing to two hydrogen atoms then form a stable molecule of water. Nitrogen present three unpaired electrons in its valence shell. Those three unpaired electrons mutual sharing to three hydrogen atoms then form ammonia NH3. Carbon present 4 unpaired electrons in its valence shell. Those 4 unpaired electrons mutual sharing to 4 hydrogen atoms then form a stable methane formula CH4. Molecules are neutral group of atoms that are joined by one or more covalent bonds. Molecules are neutral group of atoms that are joined by one or more covalent bonds. Covalent bonds are formed with non-metals only. Non-metals that bonds with themselves are called diatomic molecule. H2, N2, O2, F2, Cl2, Br2, I2. Molecules are neutral group of atoms that are joined by one or more covalent bonds. Covalent bonds are formed with non-metals only. Non-metals that bond with themselves are called diatomic molecules. H2, N2, O2, F2, Cl2 Br2I2. Sharing of electrons between non-metals only then form a covalent bond. Covalent bonds are formed with non-metals only. Non-metals, the bonds with themselves, are called diatomic molecules. Like diatomic molecules like hydrogen molecule, oxygen molecule, nitrogen molecule, chlorine molecule, bromine molecule, iodine molecule. In hydrogen present only one electron in its valence shell, another hydrogen atom also same. Both hydrogen atoms mutual sharing of two valence electrons then form a stable molecule. Each oxygen atom contains 6 electrons in its valence shell. Those 6 electrons, 2 pair of electrons, 2 unpaired electrons. Another oxygen atom also same, 2 unpaired electrons are possible. Both oxygen atoms, 2 unpaired electrons mutual sharing together then form two covalent bond between two oxygen atoms. These two bonds are called double bonds are formed. Oxygen molecules. Nitrogen present valence shell 5 electrons. In these 5 electrons, one are paired electrons, 3 unpaired electrons. Another nitrogen atom also present 3 unpaired electrons. Both nitrogen atoms 3 unpaired electrons mutual sharing together then form a triple bond between nitrogen to nitrogen. Metallic bond. Essentially all the valence electrons belong to all the atoms in the substance. Oxidation, loss of electrons, Mg plus Cl2, MgCl2. Each magnesium atom loses 2 electrons to form a magnesium ion. Magnesium ion. Magnesium gives Mg plus 2 plus 2 electrons. Magnesium loss of 2 electrons in its valence shell. This loss of electronic character is called oxidation nature. Chlorine gain of electrons from magnesium. This gain of electrons is called reduction. In this reaction, magnesium atoms has been oxidized to form magnesium ion. Mg plus Cl2 gives MgCl2. Each magnesium atom loses 2 electrons to form magnesium ion. Mg gives Mg plus 2 plus 2 electrons. In this reaction, magnesium atom has been oxidized to form magnesium ion. Magnesium oxidized by loss of electrons. Chlorine in this reaction gain of electrons from the magnesium atom. This gain of electrons is called reduction. Cl gain of electrons from magnesium 2Cl plus 2 electrons gives 2Cl minus. List of common oxidizing and reducing agent. Oxidizing agent oxygen, reducing agent hydrogen, oxidizing agent chlorine, reducing agent, reactive metals, oxidizing agent, concentrated sulfuric acid, reducing agent, cation, oxidizing agent, hydrogen peroxide, reducing agent, iron, 2 salt, oxidizing agent, iron, 3 salt, FeCl3, reducing agent, hydrogen peroxide, oxidizing agent, oxidizing agent, 6 ions in acids. Reducing agent is also ions present in introduction. Oxidation is loss of electrons. Oxidation is loss of electrons. Reduction is gain of electrons. Reduction is gain of electrons. Oil rig, substance that causes oxidation are called oxidizing agent. For example, O2, Cl2, MnO4 minus Cr2O7 minus 2. Substance that causes reduction are called reducing agent. For example, carbon, carbon monoxide, hydrogen. Oxidation is loss of electrons. Reduction is gain of electrons. Substance that causes oxidation are called oxidizing agent. For example, O2, Cl2, MnO4 minus Cr2O7 2 minus. Substance that causes reduction are called reducing agent. For example, carbon, carbon monoxide, hydrogen. The number of electrons an atom appears to have gained or lost. Oxidation number means the number of electrons an atom appears to have gained or lost. The charge that would appear an atom in a molecule is called oxidation number. Man-made systems to anomalous results can be obtained. The number of electrons an atom appears to have gained or lost is called oxidation number. How do you calculate the oxidation number in a molecule? In three elements, the oxidation number is 0. In free elements, the oxidation number is 0. When uncombined atom oxidation number is 0. Atom they cannot combine with another atom, then oxidation number is 0. In three elements, the oxidation number is 0. Sodium, phosphorus, copper, oxidation number 0. Same atoms combined together, the oxidation number of atoms is 0. Hydrogen molecule, oxygen molecule, nitrogen molecule, fluorine molecule, iodine molecule, S8 molecule. In this molecule present same atoms combine each other. These molecules, each atom oxidation number is 0. Every element is an element and its own. It is neutral, so it will have neither loss or gain electrons. The sum of all oxidation numbers in a molecule is 0. The sum of all oxidation numbers in a molecule is 0. The number of atoms are combined together to form a molecule. In this molecule, each atom total oxidation numbers is equal to 0. The sum of all the oxidation numbers in a molecule is 0. Calcium carbonate, Ca 1 carbon 3 oxygen, Ca plus C plus 3O is equal to 0. Ammonium sulfate, NH4 taken twice, SO4, 2 nitrogens, 8 nitrogen, 1 sulfur, 4 oxygen. Oxidation numbers total is equal to 0. 2N plus 8H plus sulfur plus 4 oxygens is equal to 0. The sum of all the oxidation numbers in a molecule is 0. The oxidation number of a simple ions is the charge on that ions. The oxidation number of a simple ion is the charge on that ion. Cl minus. Oxidation number is minus 1. O minus 2. Oxidation number minus 2. N minus 3. Oxidation number minus 3. S minus 2. Oxidation number minus 2. Na plus. Oxidation number plus 1. Mg plus 2. Oxidation number plus 2. Ca plus 2. Oxidation number plus 2. Al plus 3. Oxidation number plus 3. The sum of oxidation numbers in a complex ions is the charge on the ions. The sum of oxidation number in a complex ion is the charge on ions. The sum of oxidation numbers in a complex ions is the charge on the ions. SO4 minus 2. Ion charge minus 2. In this ion present 1 sulfur atom, 4 oxygen atom, charge minus 2. Therefore, sulfur oxidation number plus 4 oxygen oxidation number is equal minus 2. S plus 4 oxygen is equal minus 2. PO4 minus 3. 1 phosphor plus 4 oxygens is equal minus 3. NH4 plus 1 nitrogen plus 4 hydrogens is equal plus 1. NO3 minus 1 nitrogen plus 3 oxygens is equal minus 1. The compounds containing hydrogen, the oxidation number of hydrogen is plus 1. The compounds contain hydrogen. The oxidation number of hydrogen is plus 1. H2O, HCl, NH4 plus CH3COOH. In this molecule, hydrogen oxidation number always plus 1. Except first and second group atoms. In metal hydrates where it is minus 1. Sodium hydride, potassium hydride, calcium hydride where it is minus 1. The compounds contain hydrogen. The oxidation number of hydrogen plus 1. Hydrogen general oxidation number plus 1. These hydrogen combined with metals like first and second group atoms, then hydrogen oxidation number minus 1, like potassium hydride, sodium hydride, calcium hydride, magnesium hydride, where it is minus 1. The compounds containing oxygen, then the oxidation number of oxygen is minus 2. The compounds containing oxygen, then oxidation number of oxygen minus 2. Hydrogen present in an molecule, hydrogen general oxidation number plus 1. When hydrogen combined with first and second group, it's minus 1. General oxygen oxidation number minus 2. H2O, CO2, NO2, oxygen oxidation number minus 2. But some cases like peroxides where it is minus 1. Hydrogen peroxide, sodium peroxide, barium peroxide. In peroxides, oxygen minus 1. When bonded to fluorine, when it is plus 1 or plus 2. Dioxygen difluoride, oxygen difluoride. Dioxygen difluoride oxygen oxidation number plus 1, oxygen difluoride oxidation number plus 2. In superoxides, minus of potassium dioxide KO2. In superoxides, minus of. So, oxygen general oxidation number minus 2, in peroxides minus 1, in superoxides minus of, in fluorides plus 1 and plus plus 2. The alkali metals, first groups, are always plus 1 in a compounds. First group elements always show plus 1 oxidation number like atoms sodium, potassium, lithium, rubidium, cesium, francium. Sodium, potassium, lithium, rubidium, cesium, francium. These atoms when combined with another atom it always show plus 1 oxidation state. The alkaline earth metals like second group atoms are all show plus 2 in compounds. The alkaline earth metals like second group elements are all plus 2 in compounds. Group 2. Beryllium, magnesium, calcium, strontium, barium and rhenium. These atoms always show plus 2 oxidation state. Second group elements of beryllium, magnesium, calcium, strontium, barium, rhenium. It is also plus 2 oxidation state. The halogens, group 7, fluorine, chlorine, bromine, iodines. These atoms are minus 1 oxidation state. The halogens always show minus 1 oxidation state except when bonded to a more electronegativity elements. In Cl2, chlorine plus 1, ClO2, chlorine plus 4. Plus 4. Oxidation is a decreases in oxidation number. Reduction is a gain of oxidation number. Oxidation is a decreases in oxidation number. Reduction is a gain of oxidation number. Magnesium plus Cu plus 2 gives Mg plus 2 plus Cu. Magnesium oxidation state 0, Cu plus 2 oxidation state plus 2, Mg plus 2 oxidation state, Cu oxidation state 0. Magnesium has been oxidized, oxidation number 0 to plus 2. Loss of 2 electrons is called oxidation. Copper has been reduced, oxidation number plus 2 to 0. Gain of 2 electrons is called reduction. Oxidation is a decreases in oxidation number. Reduction is a gain of oxidation number. Magnesium plus Cu plus 2 gives Mg plus 2 plus Cu. Magnesium has been oxidized, oxidation number 0 to plus 2. Then loss of 2 electrons in its valence shell is called oxidation. Copper has been reduced, oxidation number plus 2 to 0. Gain of 2 electrons is called reduction. For example, sodium oxide Na2O. In oxidation number is a decreases in oxidation number. Reduction is a gain of oxidation number. Mg plus Cu plus 2 gives Mg plus 2 plus Cu. Magnesium has been oxidized, oxidation number 0 to plus 2, loss of electrons. Copper has been reduced, oxidation number plus 2 to 0. For example, sodium oxide Na2O. Sodium oxide present two sodium atoms, one oxygen atom. 2 Na plus oxygen is equal 0. Oxygen general oxidation state minus 2, then each sodium atom oxidation number plus 1. Sodium plus 1 oxidation state, then 2 sodium atoms present plus 2, each oxygen present minus 2 oxidation state plus minus 2 oxidation. Overall oxidation number is equal to 0. KMnO4 total oxidation number is equal to 0. 1 potassium, 1 manganese, 4 oxygens is equal to 0. K plus Mn plus 4 oxygens is equal to 0. Potassium present first group element, so potassium oxidation number is plus 1. Oxygen general oxidation number minus 2. 4 oxygens is equal to total minus 8. Plus 1 minus 8 plus Mn is equal to 0. Mn minus 7 is equal to 0. Therefore, Mn is equal to plus 7. Therefore, manganese oxidation state in KMnO4 is plus 7 oxidation state. Sodium oxide, sodium oxidation number plus 1. Potassium permanganate, KMnO4, manganese oxidation state plus 7. Thank you once again. Thank you very much.